In this video and others to come, it will be explained how the construction inside the cube, New Jerusalem, is designed. However, before that, an explanation on how to calculate the square root of 2 manually will be demonstrated so that you will understand the infinity of it. It will reveal how infinitely large this cube is without end. That which is not known is portrayed as the Holy Spirit. Scientists will tell you that the most part of an atom is space. They say so because they don't understand what can come out of that space. There are people who think that they, in their belief, don't want to be put into a box. They say so without understanding that the whole universe can fit inside just one of the millions of cubes that is inside this large cube, called the New Jerusalem. Understanding how to calculate the square root of 2 and the cube root of 2 will blow your mind into another dimension so that anything is possible. Infinity means just that. The truth will be revealed sooner rather than later, but the best is yet to come. Like Jesus' miracle, the best wine lasts.
Before we begin with the square root of 2, I need to show you that in the previous video, I said that the 12 squares needed to be folded diagonally 90 degrees so that a cube can be constructed from it. In reality, the squares are not folded, but the squares at the diagonal line are cut in half, so that, just like the hinges of a door, the two triangles of the square can form a 90-degree angle. In the diagram, you can see how one of the 8 corners of the cube come together. It is only revealed when the design is zoomed up close. Okay, now we will get into understanding the square root of 2. First of all, look at this diagram. There are 2 green squares at right angles to each other and a larger red square diagonally to them. The green squares have a value of 1, meaning that the sides, let's value them as 1 centimeter in length. Notice that the green squares are divided in 2 halves. The red square appears to have 4 equal halves that the green squares have. In other words, the area of the 2 green squares appears to have the area of the red square. So how can we calculate the length of one of the side of the red square? I will prove to you that the red square is actually a false illusion. The red square is in fact always smaller than how it is portrayed in the diagram. This is because the square root of 2 is infinite. There is always a remainder when calculating it. We believe by sight that the red square is complete, but in reality it is still unknown. There are supercomputers still trying to discover all the numbers. They are infinite. I will show you that the numbers are in fact infinite, simply by observation when manually calculating the square root of 2. The truth of the matter is that the remainder is so small relative to our existence that it is swept under the carpet, so to speak. It only affects us when we are confronted at that level of accuracy. It affects atoms much more than we are. So let's get into it. It is deeper than the outer universe as we know it. To find the square root of 2, which is the length of a side of the red square in the diagram earlier, we have to use the 2 green squares and wrap one square around the other equally so that the other squares remain perfectly square. In this diagram, the colors are different so that we can distinguish them without being confused. One of the green squares is now red, and the other is blue and pink, as in the diagram. As you can see, the remainders are purple. To wrap one square around the other, we have to first divide one of the squares into 100 smaller squares. It is done by dividing it by 10 horizontally and 10 vertically. Now we have to build them around the red square so that the square remains a square with the least amount of squares left over. As you can see from the first stage of the calculation, 4 rows of 10 blue squares are placed on top of the red square, and 4 rows of 10 blue squares on the right side. In the corner, the pink ones are placed there. That is because whatever the amount of rows are placed there, in this case 4, corner will be the square of that number, which is 16. Only the square of the numbers between 1 and 9 will fit there. The total amounts of squares used in keeping the calculation square is 96, and the remainder in the first stage of the calculation is 4. So the first 2 digits to the square root of 2 is 1.4. 1 is the red square, and 0.4 is the 4 rows of blue squares. In the following diagram, you can see the following stages to the calculation. The next stage of the calculation is another decimal place smaller. So now each of the 4 remaining squares have to be divided by 100, the same way we divided the first square. Now the total divided squares are 400, and you can see from the calculation in the second stage that the 400 squares will be enough to add another layer to the original red square. If the 400 were not enough, then each of one of those squares would have to be divided again by 100, and a 0 added to the answer of that stage of the calculation. Notice how each stage of the calculation follows the same process. Let's look at the numbers of the first stage. The first black number is 10 multiplied by 2, which equals to 20 blue squares. This is because the first blue row of squares are 10 in number, multiplied by 2, because one row is on top of the red square, and the other is on the side of the red square. The total being 20. The red 4-colored number represents the maximum number of rows that can be laid down. That red 4 is the next number to the square root of 2. That is by how much the square has now been extended at that stage of the calculation. The total of the blue and red squares are now 80, colored in black. Now you add the 80 to the 16 pink squares to get a total of 96. Minus the 100 we started with, and the remainder is 4 squares. To get those remainders ready for the next stage, you must multiply them by 100. This equals 400. As I said before, the pink numbers in the corner can only be the numbers squared between 1 and 9, as shown in this diagram. Now, to understand why the calculation is infinite is this. The sum total before the pink squared number is added always ends with a 0. But when the squared pink number is added, the last number of the sum is always less than 10. The last number of all the pink squared numbers between 1 and 9 are always less than 10. The remainder from the previous stage has to be multiplied by 100, so the last number of the remainder always has a 0. Therefore, when the total of that stage is subtracted from the remainder, there will always be a remainder. So because of what I just explained, the square always gets bigger with each calculation, but never reaches the imaginary red square talked about in this diagram. Just imagine how big the square becomes if our minds can travel deep to the size of the remainders. As for the cube root of 2, it is also infinitely similar as the square root of 2. I will end this video now and start a new one to explain why, as in this example, the New Jerusalem is infinite in nature.